Hi guys, welcome to my channel GCSE Maths and Science with Shaun. In this video, we will be learning about drawings and resultant force. What is a resultant force? Well, when multiple forces are acting on an object, the idea of resultant force is that you can replace all these forces with one single force which will have the same effect. Now, forces will not always act along a straight line. So let's take two cases. One in which the forces are all acting along a straight line, and the other in which the forces are acting at angles. Let's take case one when forces are all acting along a straight line. So please know that in a straight line there can only be two directions. We flag the directions as positive and negative. Then we add the forces up along with their signs. That gives us the resultant force. Let's take case 2 when the forces are acting at angles. The first step is that we can draw a free body diagram to represent the forces. Then we draw the scale drawing from which we can find the resultant force, and you can also check if the object is in equilibrium. We can also use a technique called parallelogram technique where two forces act at angles. We can also resolve forces, that is, break down a single force into horizontal and vertical components. Now, how to draw scale drawings? The first thing to know is that before drawing a scale drawing, read the question and observe the magnitude of the forces given. From the magnitude, pick an appropriate scale to use. Then draw the free body diagram of the force. From the free body diagram, pick up the forces and put them in a tip to tail order. The order in which the forces are does not matter. Connect the tail of the first force to the tip of the last force to get the resultant force. Measure the length of this line with a ruler and apply the scale on it. That gives you the magnitude of the resultant force. Now let us do a simple question. Example 1. Resultant force. A man is on an electric bicycle that has a driving force of 4 newtons north. However, the wind produces a force of 3 newtons east. Find the magnitude and direction of the resultant force. Let us pick a scale. From the values 4 newtons and 3 newtons, the appropriate scale would be 1 newton or is equal to 1 unit. A 1 unit represents 1 newton. Let's first draw the free body diagram. Here it is. So, 4 newtons is acting north and 3 newtons is acting east. Now let us take the forces and draw them in a tip to tail order. That is right here. So this is the first force. We have picked 4 newtons north as the first force to draw. And in a tip to tail way, we have drawn the last force, which is this, 3 newtons east. Now, we just have to connect the tail of the first force we drew, which is this, to the last force, tip of the last force, which is 3 newtons east. Measuring the resulting line using a ruler and applying the scale gives us 5 newtons as the resultant force. But when you're mentioning the resultant force, it is also important that you show the direction in which it is acting. So we use a bearing. A bearing is a three-figure angle measured clockwise from north. In this case, it comes out to 037 degrees. Now let us move on to the last question. A boat is being pulled by 3 tugboats. The boat also experiences a frictional force from the water. These forces are shown to scale on the diagram to the right. Use a scale drawing to work out whether the boat is in equilibrium. The scale is 1 unit is equal to 1 newton. Let's first draw the free body diagram. The forces are all shown here on the free body diagram. You can clearly see that there are four forces acting on the boat. Let's put that in a tip to tail order. You're drawing the first force, which is this force. Now drawing the second force in a tip to tail way. The second force is this one. And now we are drawing the third force, which is this. And then we are drawing the last force, which is right here. As we can see, this figure right here is not closed. If the figure is not closed, it means that the forces are not balanced and the object is not at equilibrium. Therefore, in this case, the boat is not at equilibrium. We can take it a bit further by finding the resultant force. We connect the two ends, that is, we connect the tail of the last tip of the last force we drew to the tail of the first force, and we measure its length using a ruler. And now we just have to apply the scale on it, and that'll give us the resultant force. Now, bye for now. See you later in the next video.